Good morning. So I hope I am one of the best speakers, but don't hold your breath because I haven't done this in a long time. But my name's Adam Shake, and I'm going to talk, just as she said, about applying SRE to manufacturing EVs. And this could apply outside of the EV world as well, just manufacturing in general. I do want to talk a little bit about me so you know who I am. Background is over 20 years in things like application development, DevOps, of course, SRE. I've been, like a tier 2 support guy. I've been all of the things. But currently, I'm a senior SRE manager at Rivian. And if you're unfamiliar with Rivian, which I hope you are familiar with Rivian, we make electric adventure vehicles. So we have a truck and an SUV that are our adventure vehicles, and then some of you guys may have seen the Amazon delivery vehicle that we make running around as well. They're pretty incredible. If you want to talk about them, come and find me. The one you see pictured there is actually mine, and the guy standing there with my wife and I is RJ. Kind of a funny story. I won't tell it now, but again, if you want to hear it, come find me. Hobbies a little bit. I love outdoors. I love 3D printing, a lot of the nerdy things, tabletop gaming. In fact, we were talking about building a custom gaming table this morning, and I really love barbershop. And I brought this up specifically because in this area, there's a really incredible barbershop chorus and a set of quartets, world-class stuff, and they're all over the country as well. So if you know about barbershop or are a barbershopper and want to sing a tag sometime today, come find me. If you don't know what I'm talking about when I say singing a tag, come find me and I can teach you that too. I've got a family. I've got a wonderful wife and 3 kids, my son Brian and our twins Bobby and Brittany, who are at home waiting for me to get there because we leave on our family vacation tomorrow morning. And we're going to fly all the way across the world back to Illinois and then get in my R1S and drive almost all the way back here because we're vacationing in Utah. So there's my Twitter handle if you want to come talk to me there as well. So I want to tell a short story first. And if you can't tell from at least one of these pictures, I'm a bit of a goofball. But in 2018, I got the opportunity to come to my first SREcon. And the way it kind of happened is I was working for a Midwestern insurance company, and the director came by one day and he said, "Hey, what do you know about SRE?" So I started Googling because I had no idea at that point. And he goes, "You want to go to SREcon?" It's like, sure, let's go. So I hop on the same flight I took here this week, staying at this same hotel out in the courtyard that's over on the other side is where I took this first picture. And this was really a kind of a life-changing or career-changing moment for me. And then I also had the Midwestern redneck epiphany moment of my first In-N-Out burger, which is also the first thing I did when I landed this time as well. So for a Midwestern redneck, that's kind of a big deal. So again, this was a career-changing event. And at that particular time, in fact, sitting in that same courtyard, I thought to myself, a bucket list item for me is to come speak at this conference. I hadn't spoken at any conference yet at that point. But I knew I wanted to speak at them, and I knew I wanted to speak at this one. So I'm super excited to be here. Now let's talk about what we're actually here to talk about, right? SRE and manufacturing. So having moved from a world of software development, right? I worked for insurance companies, ad tech companies. I built software. I was presented with a few challenges and differences at first that seemed super daunting, right? Human safety was the first one that always popped into my mind. The reality of a physical product being the outcome of the code that I wrote is second on my mind. And then also there's these legacy ideals from a tech stack perspective. Any of you who have been in manufacturing, especially in some of the legacy like auto manufacturers, know that they are very set in the way they want to do things. And you hear that phrase, but that's not how we've always done it, quite a bit. And I kind of assumed there would be a bunch more things that were significantly different. However, as I became familiar with the situation, I discovered that there were more similarities than there were differences. And that surprised me a little bit. There's still lots of code that has to be written. That code is very much still at the core of what we do. Observability is still critical to making any of the decisions that we have to make, and things still break all the time, right? Both our code, the systems that we run, but also physical hardware. So I'm thinking things like robots, IPCs, tools, and there's lots of room for improvement and efficiency, and there's even still that disconnect between the business and IT, right? We still hear things like, but we don't need IT yet when a project gets started, despite the fact that we all know that that's not a good pattern, right? All of this is described to be a scenario where SRE can play a huge role in improving processes, building relationships, and using data to make decisions, and generally making our ability to produce a product better and faster, right? And in this case, the product is a vehicle that we drive out of the end of the plant. So when I was hired, the mandate I was given was to build an SRE practice in the manufacturing environment that leveraged a lot of the principles that you guys leverage every day. Automation, CI/CD, infrastructure as code, observability, all of the things, right? And many of these things, from what I was told as I entered this industry, were not common in the manufacturing space. And a lot of the folks were like, you can't do this, you can't do that, you know, whatever. And human safety, again, was the first thing that we kept talking about. It's always at the front of my mind as we're thinking about the code we write. Because if you look at it this way, if a control system that we work on fails in the wrong state, it could affect a human. And that could be as simple as their station doesn't work and they can't do their job and the line stops, which of course costs us a ton of money every minute that the line is not producing a vehicle. But it could be as bad as a robot failing or a robot not doing what it's supposed to do and harming a human, or even worse. And so we think about that quite a bit. From day one of my interviewing process for this job, I kept hearing about how the auto industry, the manufacturing side of it, has to have air-gapped networking. That phrase came up so many times in my interview process that I just assumed it was a dead-set rule. They said that you had to have this in order to keep your system safe for a number of reasons, and the security guys in my interview would list all of the reasons out, and you know, it seemed super daunting. But clearly, an air-gapped network, right, a situation where you have devices that you need to control, but they're not connected to a network anywhere, or a network you can get to at least, presents a challenge to CI/CD, presents a challenge to automation, to observability, and all of these things we wanted to do, and the mandate I was given to kind of instill these SRE practices. So as part of that hurdle and other hurdles, we had to develop a platform to observe. That was kind of the first thing we realized we needed to do. We need to be able to see what we needed to see. And this was a challenge not only from a technical standpoint, but also a relationship standpoint. There are many stakeholders, just like any system, right? There's many stakeholders. You've got system owners, but you've also got engineers. And in the manufacturing world, there's a lot of different types of engineers. You've got process engineers, you've got manufacturing engineers, plus your standard network and platform and all of the other type of engineers, right? And they all have a part in making these production lines run. So how do we instrument the things that we have control over, which is maybe a little more simple, but also the things maybe we don't have control over, so that we can have the holistic picture of what's happening on the production floor. And then finally, at least for this presentation, the question of scale comes up. If you look at a modern manufacturing facility like Rivian's, you're talking about many tens of thousands of devices. And they're all kinds of devices, and they all have to work together to produce this product. These are IoT devices like tools and sensors, or edge computing devices, or IPCs, even micro PCs like Raspberry Pis and Jetson Nanos sometimes play into the picture. You're also talking about robots, you're talking about one-off testing equipment, and there's just so many other things. So the scale of devices we have to pay attention to is huge. And some of these are legacy devices with antiquated ways of communicating. We have devices that the only way to get data off of them is to FTP, which just seems super old, right? Super difficult to work with. But then we've also got literally brand new equipment that was built specifically for our purpose, that doesn't exist anywhere else in the world, has no documentation. You know, sometimes the code just runs in VS Code sitting on a computer somewhere. It's not even, as a service yet. So lots of challenges when it comes to that side of things. Not long after starting at Rivian, and this is the kind of the story part, my direct manager came to me and he asked me to give white glove service to a particular team. And this team was building some next-gen software for running workstations in the plant. And when I say workstations, I'm talking about the actual touchscreen panel PCs that the operators use to get their work instructions, just so we're all on the same page. And at this point, I hadn't even been given a team. I didn't have anybody working for me. I was just the manager. I didn't have any roles to hire for yet. It was really, truly just me. And this white glove service amounted to breaking down blockers when it came to things like access to resources, or networking, or firewall changes, access to hardware, access to OSs, things like that. And the vast majority of this work wasn't SRE work. It was coordination. It was, finding the right team to do the work, or just yelling at the right person sometimes to get them to actually open up a port or whatever it might be. On the surface, it seemed like I was headed for a problem I bet we've all experienced, which is SRE in name only, right? We were given a title, but not given the work that needed to be done, as many of us think it should. But as the situation progressed, and I started to get a team built, and things started to become clear, I quickly realized there was opportunity in all of this, and if I just took the time to work it appropriately, things might actually improve. And a long story, kind of less long, this ended up with us taking a very manual process of installing Linux on an IPC, something super simple, via a USB drive, and then all of the subsequent packages and applications, all the way through to now a very automated Ansible-based solution that we use today and is still being improved. So what does that look like? And we're not going to get super technical here, but I kind of want to paint the picture for a number of reasons. So to dig in a little bit more, one of the asks from this team was to take one of these touchscreen IPCs and convert it to Linux for the operator to test, right? And I was literally handed a thumb drive, and I said, and told me to go put this on there. It was a live installed distro of Ubuntu. And once I was done, and it was on the network, and everything was hunky-dory, that application team that I was giving this white glove service to would come in and install their app stack, and then the POC would go on. We did this a number of times, and all of the normal rigmarole of things such as touchscreen drivers and network settings and local firewall rules, all of this stuff kind of played out as we were testing this in a number of spots. And this continued in an experimental way like this for a couple of weeks until a random weekday around lunchtime. I got word that we needed to take a live production device now, not just a proof of concept, but an actual live production device, and get it set up for a test later that day. Now, I'll pause to say this pattern of we need this now, go, 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 became a driver to make this process better, right? I'm sure you've all experienced the this has to happen now or this has to happen yesterday side of things. That ended up becoming a very important driver for us. So I did the install, I got it set up, the app stack was installed, and that initial test on that production device went incredibly well. Everybody liked the result, and it was great. The basic rundown is we were moving from a centralized thin server or thin client-based solution to a full OS install, abstracting the vendor software back a layer and giving us control and the ability to do more with the devices. We had all this compute sitting on our production line that was being unused, and we wanted to start using it. This was the beginning of moving to edge computing and instead of depending upon our data center and centralized solutions. So we ran this way for a few weeks, moving around the plant, doing one-off installs, and we suddenly got a request to flip an entire line. And in the world of manufacturing, you've got shops, so like your general assembly. In EV, you've got battery and maybe drive unit and end of line, right? So those are shops. Individual lines are the subsections of that, right? So they said, hey, we want to do this one line. And of course, this came last minute, and we only had a couple of days to prepare. And doing one or two of these via a USB stick with manual commands and all of those things really isn't a big deal, right? It's not a big lift for us to do that. But now we're talking about doing 20 or more of these, and they need to be done correctly so the line could run later that day. This wasn't like I had a massive window or the entire weekend to make sure this was right. I had just a few hours. I quickly realized that there was zero chance of doing this manually. I mean, none, despite the team that was asking for it insisting that we do it that way. And in fact, that team even offered to throw us bodies. Hey, we'll just send people with USB sticks out. And I was like, no, like that will not work. They wanted to brute force this, and I was able to talk them off that ledge. And my now fledgling SRE team, which was absolutely tiny still at that point, and myself, we set out to design a process that might actually work. And we realized immediately that the human factor in throwing bodies, or even just our little team at this, would result in massive issues. we ran into them in droves in the first iteration of this as it is. But things like mistyped MAC addresses or IP addresses being one number off or having 2 different iterations of a login password because we weren't communicating well, these were all issues that kind of stood in our way. Not to mention, all of those things, right, still ended up causing problems even in the automated process, right? So over a time span measured in hours instead of days, we stood up a Pixie server to do the network booting and install the OS. We introduced Ansible into the organization for the purpose of doing the final configuration and the application install. And this didn't come without challenges. I was the only one on my team with Ansible experience, and not much of it as it was. And we had to deal with custom BIOS firmware on these IPCs that there was zero pattern for doing some of the pre-configuration work, and this was all kind of greenfield. We had no idea how to get through some of this. But we set about automating and making it repeatable as much as we could. The final result is we did 45 IPCs and it took 9 hours. That's better than 1 hour per device, but still a lot of time to get that many done. Now, a special note here, this manual process ended up biting us later in the year when we had to do some fleet-wide changes, and these things were still really snowflakey. So I want to highlight the process a little bit and note how manual it still was, even though it was significantly better, right? So this is the process minus 1 step. Before this had to happen, we did have to make sure that the port was on the right VLAN, which I missed in here. But we have to gather the MAC address, and we had to do that via a rescue drive most of the time, or sometimes we could get it off the thin client. We had to manually reserve the MAC address. We had to reboot the device, unplug and plug it back in because we didn't realize that they had a button because it's so tiny and hidden. Enter the BIOS, change the boot order, verify the network, reboot, let Pixie run. Then we had to wait for a post-install reboot, enter BIOS again, change the boot order back to Linux, thank you custom BIOS, log in, manually change the network and a few other settings, right? And kick off Ansible playbooks individually as the host came up. And then reboot one more time and verify everything was fine, right? That's an awful process. And yet it was way better than what we were doing before. And this still overly manual process, again, ended up biting us later in the year when we had to make those fleet-wide changes. We ended up re-provisioning the entire line again using a much more automated process we have now, and our initial flip of this one line took around 9 hours to do those 45 devices. Consistent, if not high volume issues with these hosts due to errors, changes, movements, that was all the reason we had to reflip the line, and our second image of this line took under an hour to do those same 45 devices. So we've made significant improvements, and we've almost completely eliminated all of those issues that occurred before. So what does it look like today? It looks like a lot of automation and APIs and containers and custom tooling. So we're still using Pixie for OS installs. We're working with the OEMs who provide the devices to actually pre-install the base level OS for us. We've built an AWX instance to kind of centralize a lot of our playbook running, and built a custom easy button UI, which I'll show you a little bit about, to handle some things. We have API access for IP reservations. Again, the Ansible playbooks do way more than they were before. We're using Docker to containerize a lot of things on these devices to make them super modular. We're using a Prometheus stack to monitor, and that's built into our process as well. And we've even built things like custom VNC tooling to kind of help with a number of things, and we're taking an open source first approach to things. So we've come a long way since that 9 hours to do 45 devices, and since we've matured that process and worked with vendors, we now manage over 1,300 of these, and we can do it very rapidly. We're even working on the next level of this process, codifying it even more, and working on what we're calling a full hot swap station, where we'll be able to swap a device in half the time it takes right now. In essence, that device becomes what it's supposed to be in our lab or in our office before we even pick it up and take it out to the line. So looking at this process in a little more in depth, again, Pixie handles a massive chunk of what we're doing. We really want that base OS to handle a lot of what we have to do. And they're in a better state now once Pixie is done or once the OEM has sent us the device than they were when we started the process quite a while ago. And we key off MAC addresses for all of this and ensure the proper VLAN's in place and things kind of know what they're supposed to become. AWX has been critical in us being able to get out of the world of owning the provisioning of these devices, right? So we use AWX and Ansible playbooks to centralize things, but we've built, this is an example of one of our easy buttons. We've built tools like this that allow even folks who are unfamiliar with Ansible or CLI commands to do simple things like change a host name or change an IP address or swap a device to a new MAC address or whatever it might be. And this interface lets our lower level support folks handle a lot of the work. We're constantly improving this platform. We're constantly adding more easy buttons, and it's a big part of what this SRE team now does. Now, I know this isn't going to be a surprise in a room full of SREs, but containers can make things easier to manage, right? Currently, we have as many as 14 containers running on a given IPC device, and they separate out things such as observability, our data layer, our UI. We even run Chrome in its own container for a number of reasons. And that helps us keep things very samey across our fleet, right? We want things to be homogeneous. And I will say that containerizing our Prometheus exporters does have downsides. If you haven't tried this before, we often will get a report that a device is down only because the container with Prometheus inside of it failed, right? But the device is still actually functional. So we're learning, we're getting better, we're growing, as everyone should. Observability. Most important part in my perspective of what we should be doing as SREs. And so again, I mentioned we're using Prometheus and Grafana for most of that, and we're consistently moving more devices into that paradigm from some of the other vendor tools that we use. But I want to pause on observability to stop and say, I want you to think about how you dashboard a little bit sometimes, right? Oftentimes as developers, we want to build dashboards that show us all of the things that we want to see as a developer, right? There's line charts, there's tiny text, there's a bunch of data that gets put on these dashboards. And those are really maybe very important to you. But part of our job is to build systems that make these operatable by somebody else, right? We have TVs, just like any other NOC. We have TVs in our office that have dashboards on them. And if you've got tiny text and line charts, they are absolutely useless to anyone sitting in that office. But if you build dashboards that have big blocky numbers and are really focused on glancing to see context instead of glancing to see all the details, you're actually going to gain use out of your dashboard. So I would encourage you to think about that as you're building dashboards. There are two very different use cases for those. Maybe its own topic, I don't know. I could talk about it for a long time. But more custom tooling. So I talked briefly about this custom VNC tooling. We call it Sauron, which I think is a super fun name. And in essence, what this does is it allows us an easy VNC connection to any of our Linux-based devices by clicking a button. And we can drop into that device, we can control it remotely, whatever. But even more than that, it gives us some powerful search capabilities. So it's organized by, again, shop and line and by host name. You can also then look for expired devices. So there's a last seen tag as part of this. So if I click the expired button, I will see every one of these HMIs that has stopped being available. So it's another way for us to visualize what happens. As well, because you can see big chunks with this kind of, I think it's every 5-minute screenshot that it populates up here. We can see when there's error boxes popping up on a ton of devices at one time, right? So this has really been a really critical tool in helping us service all of these 1,300 plus devices. And then I mentioned the free and open source software approach, right? We tend to, or we don't tend to, we have set a standard that we try open source first. And we do that because what we want is the configurability, we want the ability to go in and change code. We want to be able to build systems that give us a differentiation from maybe another competitor of ours. We think that the code we're writing for manufacturing systems is part of our differentiation as a business. And open source software helps us do that. If the open source software doesn't solve the problem, we'll move on. But we're going to try open source first. So let's talk about wins and challenges, right? Our biggest win from my perspective in this process was Ansible. And I know that's sometimes table stakes for a lot of you guys, right? Many of you guys have written plenty of Ansible playbooks in your life. But this was a game changer from instead of coming from a team that said, I'll just throw more bodies at it, to a position where we've been able to hand this off to the lower level support teams. It's been a massive game changer for us. It also gave our newer engineers and our newer SREs a fighting chance to actually be a part of this, right? Ansible's pretty easy to learn. It's approachable. It's not overly complex. It gave us consistency on how we applied configuration, which is the entire point of configuration management, right? And it allowed us to codify the entire thing. Our process is based on GitLab merge requests, just like almost any other software development process. And it allowed us to demonstrate that automation was a force multiplier, right? Instead of throwing a ton of bodies, we're able to throw code at it and do it with less bodies and be more effective. So other teams have also seen this and have started to jump on board. The networking engineers, the other software development teams, the teams that are outside of manufacturing Rivian, they're all starting to jump on board with this because Rivian was growing so fast, everybody was just writing code all the time and everything was manual. Our biggest challenge is, was and still is really for this one use case, is that custom firmware. It's still not gone. So if I want to go make a change, or I want to re-image, or I want to replace that device, I still do have 2 human touch points that I have to interact with that device in order to get it up and going. One before the OS install and one after the OS install because we have to change the boot order. And we've tried programmatically to do that, and it's inconsistent and it fails regularly. So it's still an issue today, and really our solution is to work with the OEM vendors to get rid of that custom firmware. So what's next, right? I'm thinking to the future. Our dream state for these IPCs and beyond them to all of the devices that we want is full hands-off deployment. I want to be able to take these devices, place them on the line, power them up, and they just become what they're supposed to be. From the host name to the IP to the app stack, there's a lot to do here, there's a lot of planning, and there's a lot of relationships to build. A lot of technology to implement, and we just to start, we need to be able to recognize when a Mac hits the network, which shouldn't be a big deal. We need to be able to automatically change VLANs. We need to be able to set up inventory and asset management so we can assign work to a given device, assign a role to a MAC address, basically. And then that device knows what it's supposed to be and a ton of other things, right? We want to take this way past these touchscreen operator stations and move into provisioning testing devices, other human-machine interface devices, tools, PLCs, like a ton of different things we want to work on. We want to move to more edge computing. We want to leverage Kubernetes on our production devices up and down the line. We want to put like small K3s clusters on these IPCs and let them talk to each other. We want to take advantage of that compute power. We want to collect more data. We're working on things like tracing, APM, and we want to work on micro downtimes as a big part of what we want to do. We want to be able to make change during line breaks or lunches or unplanned downtime even. We want to investigate chaos in engineering and dynamic workloads so we can shift station tasks to others. So if one station goes down, we can take those work instructions and put them on another one and the line can keep running. All kinds of things, right? We want to start having the mature SRE discussions around SLOs and other of the language components of SRE. We want to implement error budgets and understand how that impacts not just the software development, but also the actual manufacturing process. And then we also need to talk about the big elephant in the room, at least for us, and that's the other guys. In the manufacturing world, you've got this weird division between controls and IT. Controls is in charge of PLCs and robots and all of these computer-based devices that run manufacturing, and then IT does everything else. That division makes no sense to me. We're still talking about compute, we're still talking about networking, we're still talking about data and packets and whatever. So we have to be able to cross those lines and build those relationships. You've heard me say the word relationships multiple times. It's super critical to what we do here. Those teams, like that control teams, you often hear from them, we don't want IT involved. And they do that, they say that sometimes because they've been beat up before or not been given great service. So we need to work on those things. So I want to tell one more short story, and it's slightly different, but this struck me recently, and I felt like I wanted to talk about it because I think it's super important. It's a story about an interview I gave recently that really highlighted this particular point. I was talking to this candidate about a development position. It wasn't even on my team. And we were talking about why they wanted to work at Rivian. And this person told a story about how they had worked for a different company, but had no connection to the product at all. So they purchased that product and used it. So they knew the impact of the work that they were doing on their own end experience, which would then be the customer's end experience. And this person talked about how excited they were about Rivian's products and how they were currently not a vehicle owner at all, but really wanted to understand, to touch, feel, drive, experience, and eventually own one. They shared that they felt this was super important to being able to deliver a great product. And this conversation really struck me. It kind of hit me right in the SRE. When we talk about building SLOs and all of the work that comes with that, we have to maintain a customer focus. If your focus is on what the developers think they want, or the business thinks they want, or the executives think they want, you're missing part of the point. And in our side of the thing, it might be really easy to say that our customer is manufacturing, like the team members or the leadership, and that's true to some degree, right? We're building systems for them to use, but our systems result in a vehicle rolling out of the end of the plant. So we have to keep the customer in mind. So when you're thinking about these entire processes, you have to keep that in mind. And that's part of this adventure, this journey that I'm talking about by telling this story. So as we wrap this up, I think it's important to understand that in any of these kinds of things, it is an adventure. Now, I originally wrote journey as I was writing this, and I changed it to adventure because, well, that's one of Rivian's mottos. But I think that adventure is an important part here, right? I think that word fits really well. It's really easy to come to an event like SREcon and sit in this room and think you are far behind the curve. I remember my first SREcon, and I felt the same way at this one as well. You're thinking that your org is doing everything wrong, or that you couldn't possibly be as smart or as capable as all of the people around you. I'm sure many of you feel that way. Trust me, that human sitting next to you is thinking exactly the same thing. We're all in different places. And it's all a big adventure. It's all a big journey that we're going on. And it's not a straight line, right? And I'm talking about this from a career perspective, but also the journey of SRE in your organizations, right? You'll move forward. You'll go backwards. You'll step sideways. Sometimes you'll even completely jump ship. And I mean that both from a job perspective, but also in the entire way your organization works. I've been at Rivian for 1.5 years now, and the landscape has changed dramatically from the beginning. Remember, my first mandate was to provide white glove service to one team. And now my team is positioned to drive automation, observability, CI/CD, testing, tracing, all of the things that we want to be able to do, and we're making a big difference, and there's so much more we're going to be able to do. So I find myself looking toward the future, and there's a lot for a fledgling company like Rivian to accomplish. And what are we thinking about, right? What do I think is in the future? I've mentioned the idea of a software-defined factory. And we as an SRE team or a broader manufacturing systems team is still dreaming about what that actually looks like. It's public knowledge that Rivian is working on a massive facility to build vehicles in Georgia. And we, my team, will have a stake in what that becomes, right? We're not just going to be focused on our manufacturing facility in Normal, Illinois, where I live. We are going to be focused on all of the manufacturing facilities that Rivian has. I would love to have our processes and automations mature enough that every IPC, every edge compute device, every tester, everything we can provisions itself as soon as it has power and network. Right? I talked about that briefly before. I've actually literally dreamed of standing in that plant in Georgia as it's built and watching all of the contractors and vendors physically put the devices in place and then having that light bulb moment when someone flips a switch on network and power and we have to do nothing, right? I know realistically we're not going to get all the way there, but what if we could get halfway there? What if we could get 75% of the way there, right? I would love the team that physically has to be there to be primarily supervisory, just making sure things are okay and fixing the little things that break. I would love our processes. No, I already said that part. The team there can be tiny, right? And I've had this conversation with management and my leadership that again, SRE shouldn't grow linearly, so we shouldn't be installing a massive SRE team over there. We should be installing lots of code and let the SRE team work on that. So I think the future looks like a lot of automation, way less humans doing hands-on things, and some incredible technology and vehicles driving out of the end of that plant and every plant that we have. So that's my kind of future, and that's the story of how SRE has made an impact at Rivian already. So that's what I've got. Thank you for listening and giving me your time, and I would be happy to take any questions you guys have about anything.